Okay, so the goals today then, give you a quick and simple sort of introduction to SingleStore. I mean, if you've attended a number of these webinars previously, then I don't really need to give you a detailed introduction. I mean, the product is fairly easy to use. If you're familiar with relational technology, maybe you've worked with some other open source products as well, such as MySQL, Postgres, then that's fine too. Commercial products, there, as you know, there are many to choose from, and there are some benefits that SingleStore provides, which we'll discuss in this webinar today. The key focus and a lot of the demos that I wanted to show you show the integration with Spark, where we spend quite a bit of time, and Kafka as well. These are available in open source versions through the auspices of the Apache Foundation, and so these are very popular open source projects. Of course, they are commercialized as well by Databricks and Confluent. And the last point there, keep as much cloud-based as possible. So I will be utilizing the websites of Confluent and Databricks in order to demo simply because it's a lot easier. The open source versions, of course, you can download those, you can build those if you want to, and you can utilize those locally if you want. That's absolutely fine. If you want to go ahead and build some kind of cloud deployment, you can do that too. But it's a lot of work. And why not simply use something that's available and relatively inexpensive or no cost at all? And so you'll get to see a little bit of that shortly. Okay, so let's take a look at what are some of the challenges that we face today. Data volume and complexity, businesses need insights, analytics are evolving. So again, through my career in IT, what I've noticed is that the quantity of data that organizations seem to be working with just seems to grow exponentially all the time. Years ago, when I was a researcher, I had the good fortune to travel out to CERN, which spans the French and Swiss border, where they do this particle physics, smashing atoms together to find out what matter is made of. And this Higgs boson, something that it was reported as a discovery not so long ago. At the time of object-oriented databases, CERN was thinking of utilizing that technology as a means to capture the data, the results of their experiments, and they were talking in the region of kind of petabytes of data. I mean, that's kind of jaw-dropping numbers of the day. Nobody really had stored that volume of data. Today, people throw around hundreds of terabytes, petabytes is sort of fairly standard in terms of the quantity of data that they want to work with. So that is a significant problem in terms of how do we deal with this data? How do we ingest it? How do we do analysis of it at speed and at scale? That's quite a challenge. And then the other thing, as in many industries, I'm sure you've observed it, deregulation, competitive pressures, and so giving insights into senior management, showing them the results, giving the information at the fingertips to make these business decisions becomes very important. So those guys tend to be less concerned about the back end. It's a black box as far as they are concerned. What they're looking for are answers. They're looking for things that will help them make those business decisions much faster, look for opportunities, fend off threats if necessary, and do so very, very, very quickly. The last point there, the analytics, historical to real time to predictive to AI. Everybody's an AI company today, but go back in time and a lot of the static data that we used to deal with in terms of data warehouses, well, it's really not enough anymore. We need to be able to combine that data with a lot of real-time data that's coming in. So think about IoT, wearables, sensors, these kind of things, plus combine it with historical data to give you the kind of full picture, if you like. That is the way that a lot of organizations are going, and rightly so. You want to get the best out of everything that you have. So some of the things that companies, applications really struggling with this SLAs, meeting these service level agreements, quite difficult, quite a challenge. Rising costs and complexity. So the complexity really comes about because you're trying to do a lot more. And costs, again, that if you end up having to use, say, half a dozen to a dozen different products in order to solve the same problem, then that can be, again, quite a challenge. It introduces a lot of unnecessary requirements. Climbing concurrency demands. I'm sure all of you have a smartphone. You do your online banking on that. So think about the challenges that poses to financial organizations, for example, and there are many other cases as well. we can carry our bank around in our pockets today and do all these transactions and all these kind of moving money around and so on. That introduces a lot of demands upon existing systems. Okay, so one of the things that we focus on specifically at SingleStore is this notion of data-intensive applications. It is a product that is eminently suited to this type of domain. So what do we mean by this? Well, it is applications that exhibit some or all of these sort of attributes that we see here. So the data size I've already talked about, the terabytes or even up into the petabytes. Speed of ingestion is important. We need to be able to get the data in quickly, be able to process it, get insights. Latency, we cannot wait for minutes or hours for results. We need to be able to process data quickly. Complexity is introduced as well. Potentially you could be doing a large number of joins, for example. There are products out on the market that are specifically optimized for those problems, but they are very, very niche. And therefore, having a general purpose solution to this could be very useful. And again, the concurrency issue, which I alluded to just a couple of minutes ago. All right. So today, if we have a look at this kind of nice big picture, if you like, I think you can see that there's a range of capabilities that we have. So specifically, what I plan to focus on is obviously the relational aspect. I look at a little bit at geospatial. Okay, we'll show you an example of that. And not so much the key value, more in terms of comma separated value, but for Kafka, as you know, it uses this sort of key value sort of format, but we don't really utilize that. But I will be using a CSV sort of format. And then on the left-hand side, we are going to be doing a little bit of streaming here, okay, using Spark and Kafka. We're going to do some transformations as well. And I'll show you this kind of bulk load capability, which is very useful as well in terms of, I mean, it's small scale, but again, you can scale up and that will work absolutely fine. Keeping everything cloud-based, this managed database as a service, I'm a big fan of this approach now, simply because it avoids having to install stuff, configure it, and having to overcome problems in terms of local installation. Over the years, I've burnt my fingers many times. Had challenges in terms of getting things working properly, and now what I find is the cloud-based approach. These systems are reliable enough that most organizations are moving to the cloud in one form or another, and eventually probably everybody's going to end up on there. So you let somebody else, essentially you're renting somebody else's resources there. They are taking care of the infrastructure, the plumbing, updates, and all of those kind of things. You focus on the business. Your organization focuses on the business, what you do best, what you want to sell in terms of your products and services. That's what your focus should be. Okay, let's have a look. Okay, so I don't have too many slides. As I said, we've got quite a lot in terms of the demos, and therefore I'm keen to sort of jump straight in. But let's talk a little bit about Spark then. So Spark, awesome technology. I say that with a little bit of expertise and experience, since I happened to join SingleStore from Databricks, okay, where I was actually teaching Spark to their partners. So we'll look at the SingleStore Spark connector today. So I'll show you some of the features and capabilities of that. There are some additional benefits that we can achieve, this notion of push down, which we'll have a look at as well. Okay, so it means that we can push queries, partial queries from the Spark environment to SingleStore, and essentially let the database management system, let SingleStore evaluate those as much as possible. Okay, it lets the database management system do what it's good at, which is to be able to process data and do it at scale. The third point there, in terms of Spark data frame operations get translated to true SQL and executed with high performance and excellent concurrency. I'll show you a couple of examples of where we work with data frames. And then the last part there is this capability to compress data to expedite the ingest process. So we can actually use Spark as a way to get data into SingleStore. Think of it like an ETL, if you like, as a way to push data into this environment using this connector, and we can do it. It can ingest the data at scale. Okay. The other example that we'll focus on in the Spark environment is a little bit of machine learning. Okay, so I've got a real problem. using some actual data. This is taken from a Kaggle competition. Okay, I'm going to discuss that in more detail for you. So here is the kind of overall process and the flow in terms of how we might approach machine learning. So machine learning as a concept, as an idea, I mean, the principles have been around for a very long time. The problem, I think, has always been enough compute power to be able to do these things at scale. And so with the advent of cluster computing, with the advent of distributed processing, it's very, very cheap and easy and quick now to be able to just fire up a machine in the cloud, be able to run your algorithms, get some insights, and you just pay for what you use. You know, typically you're talking about pennies, cents, you know, a few dollars maybe. This process, as you can see, consists of 10 steps. Today, unfortunately, time is the enemy, so we'll have the opportunity to go through these first 5 here in terms of actually creating a model and then just evaluating it. But data science, machine learning is an iterative process. I mean, you go through, you go back, you evaluate, you change your model, evaluate, and perhaps decide to use a different model, or perhaps you decide to use some different data. So these are all part of the process. Okay, so without further ado, let me just briefly show you the diagrammatically the 2 approaches that I'm going to evaluate initially. Okay, so we're going to look at this SingleStore Spark connector. Okay, here we go. And what I've got is my Spark is running on the Databricks Community Edition. Okay, and we've got this SingleStore managed service in the back end here, which I've fired up, and I've been, I created an account before I joined SingleStore, so I've been burning my way through the $500 that they provided. Curiously enough, I've now got more money in that account than I started with. I think that has something to do with the fact that I work for them now, but you'll get to see that in a couple of minutes. Okay, and then the thing that we'll compare against, we'll do a bit of JDBC as well, just to show you that it can be done that way as well. So it's entirely possible. It supports it. It's a MariaDB jar file in terms of where the JDBC driver is. Okay, and we actually use the MySQL connection you'll see within the notebook momentarily. So I'll do a quick and rudimentary kind of performance comparison between the two, and then from there we'll move on. I'll do a bit of machine learning to show you how we can do that, and then show you an example of pushdown as well, that we'll get to see how this actually works in practice. And I will switch to the Databricks environment. All right, so this is a Community Edition. CE. This is a free account that Databricks provides. It's very limited in terms of capability, so you just get a driver, no workers, and it's community optimized. But the thing is, it's very capable. For small scale tests, for small sort of POCs, it's ideal. I mean, again, I had to install nothing locally. Everything's in the cloud. It gives me the opportunity to run these Python notebooks. The only thing that I've had to do is I've set up a cluster. So let me just duplicate this window to show you. Okay, so this opens up the same window here again. And if I go to the left-hand side here, okay, just selecting compute from the left nav there. There is my cluster that I have running. Okay, so this is just a driver. That's all I get. I don't get any workers as part of this environment. I'm running a LTS version with machine learning here, and I've just attached 2 libraries here. One is the SingleStore connector, okay, which is just done through Maven coordinates. Okay, it's the first one here, and the second one is just the jar file. Second one there, as you can see, and that was just uploaded locally. So both of those are installed, and you can see the sort of the green there, which shows that they are ready and can be used immediately. And that's all the work that I had to do. Nothing to configure locally. And now over here, what I have is got some Python code. This notebook is attached to my cluster, okay, in the top here, as you can see, and it's ready to run. Okay, so what we'll do initially then is take some credit card data. It's in a CSV format. You'll get to see it in just a moment, and I'm simply going to read it in. I've given Spark a little bit of information that there's a header, and basically figure out the schema for yourself. You know, find out what's actually in there. There we go. Let's just execute this. Right, just give Spark a moment to read that in, and then we'll take a look at the data in a bit more detail once it's finished and actually finish creating the data frame. There we go. So that took about, what, 20 seconds or so. And let's do a count. How many rows do we have here in this data frame? Okay, we've got about 285,000 rows of data there. And let's take a look at the structure here. What does it actually look like? There we go. And so what it is this data set consists of, let me see, we know up here it's 29 plus a few more. So we've got all these fields. Okay, there's the schema, which are labeled V1 to V28. Okay, and then we've got a couple of other columns. We have a timestamp at the beginning here. Okay, but that is not a time as in, you know, that we see on a clock, for example. This is purely for just organizing these, and so you can sort them into some kind of order, ascending or descending. And on the end, we have the amount of the transaction that took place. And then finally, we have the class, which has one of two values, either 0 or 1. So either it was a non-fraudulent transaction, in which case it has the value 0, or it was a fraudulent transaction, in which case it has the value of 1. Now, we are not told anything about what these other columns relate to, V1 to V28, nothing. I mean, they just consist of numbers there, as you can see. These floating point, double, that's all. So we don't know anything about what those really relate to, but that's okay. We'll take a look at that in a moment. All right, so let's just take a look. What is the kind of ratio of fraudulent and non-fraudulent transactions that we have? Okay, so this is real data, as I said before, that is available through Kaggle. So actually, the number of fraudulent transactions here is very small. It's tiny, only 492. And the rest are non-fraudulent. And that's a good thing, okay? That's what we would like to see. So immediately you can see that the fraudulent transactions are swamped by the non-fraudulent transactions. So any model that we try to build is going to be skewed one way or another. I mean, it's not going to be particularly good. So we have to do a little bit of manipulation of the data in order to be able to take that a little bit further. More about that later. Okay, so let's set up a connection then to SingleStore. Okay, so I've got a separate notebook here, which is basically just got the details of where the server is, the port number, as well as my password, and that just runs that to set it up. Okay, and we just set up a couple of variables here locally. And then what we'll do is here, I'm simply going to write that data frame into SingleStore using the Spark connector that we have. So we'll time it, okay, just to see how fast it can do that for us. It's using a bit of compression there as well. Okay, so LZ4 compression, and it will create a table for us within a database in SingleStore called fraud detection. Okay, so there we go. Okay, so according to this, the wall time was 22.2 seconds. All right. So let's do the equivalent using JDBC. Okay, so here I've set up the same thing, just set up the connection properties, and then let me do the same thing here, repeat it with JDBC, time it as well, see what we get. And this will connect to the same database, and it will use the put these values into a different table, slightly different name there, TX2 rather than TX, which is what I used above for SingleStore. So as you can see already, you'll notice visually, and you can see that it's taking somewhat longer. Typically, for the number of tests that I've conducted over the last couple of days, it's on this particular data set, normally it's about twice as slow using JDBC versus the SingleStore connector. There we go. So the wall clock time there, it gives me as 42 seconds. So as you can see, it's roughly twice as slow as the connector. So already you can see some benefits there in terms of using the connector to be able to load the data into the database system. And if we just switch across, okay, just take a look over here, and we can just let me just select the fraud detection database. Okay, I'll do that from this side here. Okay, just make sure I'm in the right place. I'll show the tables, okay, and there should be two of them. Indeed, there are. There we go. These are the two tables just been created. Okay, first one is through the SingleStore connector, and the second one using JDBC. And just so that you know that I've got nothing up my sleeve, let's just take a look at the data on this side. So let me have a look at 5 rows from the table created by SingleStore, and there we go. We can see time column. We've got these 28 additional columns that we don't know what these really stand for. We're not told enough information. And then we've got the amount and the class on the end. So it all looks good there. That's gone in safely. And let's take a look at the count. How many rows there are? Well, it tells me it's at 284,807, which is correct. That's the number of rows that we saw in the data frame. And let me repeat this then for the other table. Again, just so that you can see, nothing up my sleeve. Okay, so there you can see the structure is the same. And again, and just do a count of the number of rows. It's identical, 284,807, okay? So immediately there, the connector gives us some performance benefits and gains that we can get simply by using it to get the data into SingleStore. All right, so let's move on and then do a little bit of machine learning with this with this data. So let's connect this, okay? And again, I'll just do the setup. It's done. Set up a couple of environment variables here. There we go. That's all done. And the first thing I'll do then here is, again, I'll time it, see how fast SingleStore, I can get the data from SingleStore into my Spark environment, into this data frame. And there we go. You can see it's almost instantaneous, okay? 474 milliseconds, very, very fast. Find out how many rows that we have in this data frame, just execute that, and it should come back. There we are, it's 284,807. And again, show the structure, take a look. Should be quite familiar to you by now. I mean, you've seen it several times already. There we go. That is the, we've got these V1 to V28, the amount, the class, and the time. Okay, so at this point in time, one good thing to do would be to drop any rows that maybe have null values. Okay, we could do a bit of feature engineering. In this case, I think if we run this and then we count the number of rows again, we'll find that it's the same, simply because this data set, which perhaps rather unusually is complete. There are no missing values here, but that is something that we could do as part of the process in terms of our data science activity. Okay, so this takes a moment or two to finish. There we go. So that's done. And it gives me back a result that's the number of rows is the same. No change there. That's okay. Okay, so what's next? So the next thing to do then is to kind of sort out that problem, the fact that we've got the vast majority of transactions being non-fraudulent and the number of fraudulent transactions being tiny. Now, if we were to use the original data, that's going to cause some difficulty. I mean, it's highly skewed in one direction. And therefore, one accepted practice is to be able to reduce the data set that's rather large and then build a model on that. Okay, so that's what we're going to do. So the first thing we do is just separate out the two different classes here, create two separate data frames to filter those out. Okay, class is 1 and class is 0. There we go. And then for this Non-fraud data, which is the overwhelming majority of the data, we're just going to sample 1% of it. Now, you might say, why 1%? Well, it gives us a much smaller number to work with. You could change it to 10% if you like, or 15 or 20. You try it with different values as well. That's absolutely fine. But I've done this experimental analysis before, and usually something like this is fine, just for initial first cut sort of model building and development. Okay, and then we just take that, concatenate it with the fraudulent, sort it on the time field to get back something that is smaller. And again, if we look at the structure again, we will see that it's the same as what we had before. Again, those fields are unchanged. Okay, that command is just still running. And actually, we've got now down to 3292 rows. So it's a lot smaller than before. Okay, just taking a moment. There we go. So here we can see the outcome in terms of the display. So of course, those columns are all still there, no change there, but we've just drastically reduced the overall data that we're going to work with. And the rest of it is just straightforward. It's just creating a sort of a training and test split, 70% and 30%. And so we're going to use the training data to create our model, and then we are going to apply that model to the test data to and then see how accurate were we in terms of predicting whether it was fraudulent or non-fraudulent. Yeah, most of the time there is actually spent on the count. I was kind of keen to get those numbers out just to get a sense of what is the distribution. But so the training data consists of 2281 rows and the test data of just over 1,000. So that's how it's the 70-30 split has gone. And then finally, just really use logistic regression here, simply because we have two possible outcomes, 0 or 1, true or false, fraudulent, non-fraudulent. And for that, this particular type of machine learning algorithm is ideal. And that's all we're doing here. Simply create feature vectors, apply this logistic regression from the Spark environment, and then just below, once this is finished, we'll be able to make a prediction. Once it's built the model on the test data, and then we get a sense of how accurate were we. We can check to see what Spark's up to. There you can see it's doing a fair bit of work. Okay, because I think I've asked it to do, let's have a look, what's that? 1, 2, 3, 1, 2, 3, 100,000 iterations. Probably it's overkill, but that's okay. I mean, that's what cluster computing is for, and we are hammering our driver on the community edition environment, but it's okay. You know, let's see if we can get a decent model out of this. There we go. So that took 1.42 minutes. So maybe I could reduce the number of iterations it has to do somewhat smaller, maybe 10,000 or 1,000, and then just take that model, apply it to the test data, show the results here. Right. And then finally show us the accuracy of the prediction just below. But I'm keen to just show you what its output here, just so you can see. There we go. So again, you'll see that we've got these columns, but as part of this process, what it's done is, because of the features, there we go. There are the features that have been used to create the model. There's the raw prediction, the probability, and all these useful things. So if you're a data scientist or machine learning engineer, you will understand what these mean. And finally, in the last column there, the prediction, way over here, okay? This is the thing that we're interested in and want to compare to see, you know, how well did we do? Did we get something that's pretty good or not so good? And so finally, we can output the confusion matrix at the bottom here, just to get a sense of this first kind of pass, this first model that we built. There we go. So let's have a look. So overall, we've done well. So there is the number of non-fraudulent transactions that were predicted and accurately agree with the fact that they are non-fraudulent. There is the prediction in terms of 125 fraudulent, and that agrees in terms of that is the actual value. We've got a couple that didn't work out so well. So this one here, 8 of these were predicted as fraudulent, but in reality were not. Okay, so that's a type 1 error. So that's okay. It maybe just annoys 1 or 2 of our customers, or 8 of them in this case, perhaps, or I don't know. I mean, 8 transactions could be several people. We don't necessarily have a one-to-one mapping between transactions and people. So that's kind of acceptable. The other one here, slightly larger, but still quite low number. This is the case where we predicted that it was not a fraud, but really was. Okay, so that's a type 2 error. So as part of this process, then we iterate, we go back, and perhaps we can improve the accuracy of our model. So with this particular example, as you can see, we can get data in and out of SingleStore very fast. We can use the Spark connector as a kind of an ETL. Getting the data back is, again, milliseconds in terms of the volume that you saw there, roughly sort of 300,000 rows. Using the Spark environment, then we can do some machine learning on that, and then ultimately, perhaps iterate through this process and develop a better model. Maybe refine the data, perhaps do some normalization of the data. There's a whole range of things that we could do. Unfortunately, again, time is our enemy, and we don't have the opportunity to look at that. But if there's something you're interested in, please let us know. Okay, we'll be happy to put together some content for that. All right, so let's now look at this push down, which I talked about as well. Okay, very useful feature. So what I'm doing here is, in this one, I've got some weather data. So this is weather data for major cities of the United States for, I think it's principally 2016. So it's got a range of columns, okay, which we'll look at in just a moment. And again, I'm just reading in CSV file into a data frame in my Spark environment. And we can count the number of rows here. How many have we got? We've got 16,743. And then just take a look at the data frame. What's the structure look like? So here we've got a whole range of columns. So we've got, oh, pardon me, what I need is an arrow. Precipitation, okay, the actual city, some code here. And if we scroll to the right, we can see some additional details, such as the state here, the average temperature in Fahrenheit, the maximum temperature in Fahrenheit, and the minimum temperature in Fahrenheit. And we also have a bit more information on the end there in terms of wind direction and wind speed. Okay, so this is a fair bit of data for 2016 for cities across the United States. And so one of the things that we would like to do is maybe do some analysis and conversion. For example, convert, a simple thing would be to take the Fahrenheit values and convert them to Celsius. Initially, let's just take a look at San Francisco here. And here you can see the plot for the max and min values across that entire data set that we have. And that runs from roughly January 2016 all the way to January 2017. And looking, just a cursory look at that plot, well, that looks good. The summer months look hot and the winter months are cooler. So that seems sensible. And here, let's just set up a connection to SingleStore. Again, get our connector variables set up, and then take this data frame and just write it into a table called temperatures in the weather database. So that should be pretty fast. It's 2.6 seconds to do that, right? So it's only 1,000, I think, that was it, a couple of thousand, 16,000 that in terms of rows. So that's now created a table for us in SingleStore. That's great. Okay, so this is the kind of prep work, if you like. And now let's do something with that data. Okay, so again, just run the setup, passes my credentials to the SingleStore cluster, set up the environment. Let's read that data back from SingleStore into the Spark environment. It's pretty fast, 0.44 seconds. And then here, what I'm going to do is I am going to create a temporary relational table in Spark, and I'm just going to call it temperatures. So that data frame now, the reason for doing this is so I can work directly in SQL on that. That's one reason for doing that. All right. And the next thing there is I've just defined a simple Python UDF here as well. It literally takes a Fahrenheit value, converts it to Celsius, and I just register this with the Spark environment. And once it's registered, I can use it. All right. And then here, what I've got is I've got a query. Standard sort of SQL. I'm just saying select city, state, use my UDF to convert the maximum temperature in Fahrenheit to Celsius and call it max C. Do the same for the minimum temperature, call it min C. From temperatures, okay, remember that's temporary table, sits in the Spark environment. Where city is San Francisco. And then I've appended this thing here at the end, this explain. So what this will do is it gives me details of the physical plan. How is it actually going to evaluate that query? And if I look at the physical plan, what it shows me is that this sends, it does push down to SingleStore, okay? So I get a scan and a project operation on the SingleStore side. And it will do it for San Francisco, and it will look up city and state. And the Python UDF, because it's registered and exists in the Spark environment, that gets executed locally. So that cannot get pushed down to SingleStore, all right? So with this capability, push down for those things that make sense, which the backend database system can manage well. So the city and the state, and we're filtering by city, for example, San Francisco, although that makes sense. And that leaves the evaluation of the UDF on the fields max and min to Spark, since that's where the UDF lives. Okay, it's described and registered on the Spark side, so it has to execute on the Spark side. But then Spark is pushing the rest of that processing down to SingleStore. Now we can actually run that query like so, okay, without the explain, actually execute that for us, and there we go. So there we get the result back, and these columns represent the values max C and min C, just converting those Fahrenheit values to Celsius, and then just filtering by San Francisco, and then we're just getting back a couple of those columns, such as the city and the state. Okay, so there you can see a practical benefit again in terms of combining SingleStore with Spark. So Spark does what it's good at. Anything that it thinks that the backend relational database, in this case SingleStore, is good at, it will push those operations down, and SingleStore will handle those really well, and then be able to send the results back to Spark to finish off. Okay. All right, so that is all of that. Let me just run one more thing then, okay, which we need to do for the next demo, which is going to be using Kafka. Okay, so all I'm doing is taking some data. Oh, pardon me. Let me just attach this before I execute it. Okay, so this is some sensor data. These are like sensors that could be located all over the world, various geos. There's 1,000 of them. I created this using a kind of random number generator, and we can have a look at the data frame, see what's actually in there. So it consists of 4 columns. There's a unique identifier. There is a name field, and then I've got latitude and longitude. And there's 1,000 of these. So one nice thing is just to have a kind of a visualization. Let's just take a look, see if we can create a map of the world just to show us what the distribution of these sensors is around the world. And if we do this, there we go, we see this world map. So as you can see, That's a pretty good distribution. There's a couple of places that don't seem to be covered very well. So I noticed that here in Africa, Sahara Desert seems to be not well covered, and in the southern Atlantic Ocean, we seem to have a hole here as well. Doesn't seem to be particularly well covered. But overall, the distribution of our sensors globally seems pretty good. And if I hover around, I can get to see what the unique identifier for each of these points are, along with their latitude and longitude. I think in the UK, where I am, there's one which is right in the far north, somewhere near Scotland. So, but that's the data set that we've loaded up. And if we take a look over here and just go down to take a look at the sensor readings database, and then just have a look at this sensors, limit to 5, just return the results to us. Oops. I just run this again. Oh, my apologies. At the moment, I think I need to, let me just have a look here. Temperatures all use weather. Did I actually execute that? Let me just check that. My apologies. Oh, pardon me. I jumped the gun a little bit. So that's all done within the Spark environment. Again, what I forgot to do, and I'm sorry about that, is actually send the data across to SingleStore. So I was wondering why the table was empty. Okay, so now, as we've done previously, take that data frame, write it into SingleStore. All right, now notice, if we just go back here a sec, remember that here, originally we had 4 columns: ID, name, latitude, and longitude. And on the SingleStore side, if we now take a look at that table, we've actually got 5 columns. Okay, let me just move this up. You can see here, okay, latitude, longitude, unique identifier, name, and now, at the end here, we've got this extra column that's appeared. And so this is something that SingleStore can do to handle geodata. So if I show you how I define this table all the way up here, what I've said is that there is this column. It's a geography point consisting of a pair of longitude and latitude. And so as I read the data in, automatically SingleStore will create that point type for me, and it will add that in. So you can see this is a great way to kind of bulk load data in, and it will process that and then add this extra column for us as well with this geographical type. Now this is useful because what we can do then is we can do some queries in terms of figuring out then, you know, what particular landmass do these sensors reside on. And so there's another table here consisting of continents where the various continents, Antarctica, Australia, Asia, Oceania, Europe, Africa, North America, South America, have been defined using some sort of polygon coordinates here, okay? And if we take a look at the map, I think this is, there we go, just shrink that down a bit. You can see that some of these, South America, for example, could be represented as something that looks kind of roughly like this, okay? So we could define coordinates that match those. So it's not going to be an exact in terms of, you know, the accuracy may not be there, let me put it that way, okay? But it's enough, okay? And the more points that we would define as part of this polygon, the greater the accuracy would we get. So we put some in just to give a rough outline of each of these continents, so that could be useful. So as you can see from the distribution, we know that quite a few of these sensors reside on land masses, many of them don't, they sit in the ocean. So one of the queries we might want to do is to find out where do these actually, you know, where are these sensors to be found? So that could be quite useful. Okay, so That sets up this sensors table for us. We've got this table of continents as well now. And how about then if we start to generate some data from these sensors to be able to read them in and to be able to get them into a SingleStore and then do something useful with that, some useful queries. And then we've got a couple of examples just below of how we could do that. So one of the things that we could use then is, let me switch to this. Okay, this is a virtual machine where I am running a producer and consumer for Kafka. So I've got a bit of Java code. This is just taken from the examples provided by Confluent. I've just changed them very slightly to for the particular problem that I'm trying to address. And so I've got a producer and consumer. So the producer is generating these values for these sensors, okay, some temperature readings, and then it's pushing them up into the Kafka, into the Confluent Cloud. And then from the Confluent Cloud, it's coming back down to a consumer, which is another piece of Java code. And then from there, it's writing it back up into the SingleStore managed service. So as you can see, this process involves a number of hops from here to here to here. Okay, it works. All right, it will function. That's absolutely fine. Okay, a better approach would be like this. That yes, I've got a consumer which kind of simulates the fact that I've got some data that I want to get into the Confluent Cloud. Imagine that the sensors are sending this across to Kafka, and then from there I can massively ingest all of those directly into SingleStore without having to write any other piece of code. Okay, and I'll show you the definition of the pipeline. Very straightforward, easy to do. Okay, so let me just show you the code from this side. Okay, so on here, all I've simply got is this producer, and let me just generate 100 messages, and the topic is just called temp, short for temperature. There we go. So that piece of code will just run and just very fast. There we go. You may have caught that at the end there. And on this side, what I'll do then is I'll just run the consumer, which is again just a bit of Java code, reading those messages and then pushing up into a SingleStore for me, and it will just hang and wait there for more. There aren't any more, but that's okay. We'll just leave that for now. So on the SingleStore side, if we come back and take a look, all right. Right, so I see at the moment that there are 200 values in that temperatures table because I ran this a little bit earlier as well, which we also with a value of 100. So it's been done twice through that sort of multiple hops, producer and consumer, writing out up into the managed service here. It works. I mean, it's done that. But like I said, a better way, particularly if you're dealing with massive quantities of data, is to create a pipeline. Very useful. And this is how I've defined my pipeline. Okay. So I really need a box like so. So I've just told it, given it some details about where to connect, my username and password. Yes, I know it's risky showing it to you live. Hopefully none of you are sharper-eyed enough to be able to go in and mess up my Confluent Club. That's okay. I mean, it's going to be torn down very shortly anyway. And that is something that is sitting there. Okay, and I can start this pipeline. So I've defined it. All right, run that already. There we go. And we can just show this pipeline. And by the way, this pipelines not only works with Kafka, it works with other technologies as well. So for example, you could have something sitting on an S3 bucket, for example. And so that pipeline is running, it's waiting. And so on this side, back here, what I'll do is I will generate and give it the value -1 here, basically endless loop. Keep generating messages and keep sending them up to Kafka. And then on the SingleStore side, there we go. So that will just keep going forever until I stop it. And on this side, we can take a look. And let's have a look. How many values do we have in this table now? It should be growing. Well, it's up to 366 now. Okay, so it's consuming those messages. If I run this again, it's now 431. Okay, down here. So that table is growing and the data is being fed in. And so as that data is kind of arriving, now I can do some interesting things. So I can start working with some joins across these tables. I can do a simple thing like this, for example, just find out, select sensor ID count from temperatures where the temperature is greater than 70, temperature less than 100, do a group by, an order by, and there I get some values back. That's on that sort of live data there. I could also do some interesting things like, just find out the maximum temperature here. And based upon latitude and longitude readings, for example. And again, remember that data, it's streaming in, and I can run this on that. And again, I get back these values just below. And then finally, this thing here in terms of geo. So remember, we've got the continents created, and we've defined some polygons to represent the sort of rough outlines of the major continents. So we can then do a join of this across using the sensor table that we defined earlier, and basically just ask, how many of these reside within the various continents, give me the sensor name, and there we see the result here. So this is ordered by continent, and then within that by sensor name. So I think I'm limited here to 300 rows. So if I just change this to something larger here, there we go. That should just go down here and then just run this again. There we go. So it tells me here on the right hand side 432 rows. So given that we know that there are 1,000, the remaining 600 odd sensors then must reside in the oceans. Okay, so we see a roughly sort of 60%, 40% split in terms of landmass versus ocean. Okay. Very finally, quickly show you a little bit of metrics in terms of Grafana. Okay, so there are some dashboards that it's possible to download from our website, which will give you the ability, let me get rid of this arrow here, which will give you the ability to create these, to sort of monitor the system, have some insights into the metrics. I mean, from this environment already, we have the ability to, check to see workloads. Okay, we can profile, for example, we can see the active queries. So there is useful tools available from the SingleStore Studio if you want to do so. But if you want something a bit more sort of fine-grained, just to show you how the system is performing, then this is a great way to do it. And I've just set this up using the standard MySQL connector. Again, just given it the location of the server, passed in my credentials, my username and password. And I think in this particular example, we provide quite a wide range of dashboards. So let me have a look at, see if there's any, right, this one currently has no data, not enough, I think, processing time for this to accumulate sufficient data. See if there's anything else we can have a look at. Again, no data for that one. So a couple of them have been populated. They haven't been running very long. That's the thing, I think. So SingleStore, single database for data-intensive applications. So hopefully I was successful in convincing you the ease with which you can integrate SingleStore with these kind of big data technologies, the Kafka and the Spark. The tools that we provide, the Spark connector, for example, gives you a lot of great performance, compression, and lightning speed in terms of getting data in and out of SingleStore. So that's a great way, as I said, for sort of ETL type capabilities, but also combining the strengths of Spark in terms of its machine learning support. And so you can use SingleStore as your system of record, keep your transaction sort of oriented data in there, and then be able to run these machine learning algorithms at scale. And then for messaging, as you saw, the pipelines, that is a really awesome feature in terms of being able to ingest vast quantities of data into SingleStore. You saw this simple bit of code that I showed you to be able to do that. Supports a variety of different formats. I happen to set it at CSV. Again, just providing the connection details to where it can get that Kafka data from. In this case, it happens to be Confluence Cloud. And even at this moment, my sensor generator is still running. I'll have to terminate it at some point. But where can you use SingleStore? Well, the thing is that you may have the opportunity to do a greenfield development if you are fortunate to do so. In my experience, these things are rare. You know, if you are able to do this, well done. That's a great opportunity to start from scratch. No baggage, no legacy to worry about, and you have the opportunity to build something from the ground up. This is really a lot of modern applications, new apps, operational analytics workloads, using these kind of modern tools such as Node, React, and so on. Many of you perhaps reside much more in this space where you are using something else for which SingleStore can augment and help you get more out of what you already have. Not necessarily replace it, but act as something that can help, you know, in terms of getting better data, better analytics, better insights through this augmentation. And sometimes, perhaps, you know, you may require to consolidate and replace something that you already have. And again, SingleStore could be a great replacement for that. So the ability to support multiple types, multimodal, geospatial, you saw a brief example of that, relational, obviously, it's its sort of key strengths, but key value as well, JSON, change data capture, system of record, you saw some of the ingest capabilities we talked about, push down benefits that we saw as well, and the ability that you can run this anywhere. So today, I try to focus as much as I could on the cloud, simply because I think that's where the future lies. And for me, it's a great convenience because there's far less for me to have to worry about locally on my laptop or my environment. And if I think, and you know, in terms of the kind of conversations that I've had with business people over the years, it becomes quite a burden for them to have to manage their own IT infrastructure. Like I said before, you know, pay somebody else to do that. They can do a far better job, probably. You don't need the clean rooms. You don't need to hire specialists to be able to do that. They will take care of that. You just rent those resources for the time that you need them. And these days, the cost of all this is very, very low indeed. Okay, some examples very quickly, some where SingleStore is actually literally single store, you know, one system to rule and to replace multiple systems. There's some examples for you. We're happy to discuss this with you further. If you want more details, we can go into that with you offline. And thank you. So apologies, we are a little bit over. I think that comes of having to do demos. Practical things are always much harder to show, but happy to take a couple of questions there. So Diogo, over to you, sir, and see if we have some questions that I can assist with.
So thank you, everyone. We will now begin the Q&A session. As a reminder, the Q&A function is in the lower right corner of the GoToWebinar console. So if you have any questions, just drop a message there and we will answer it. We already have one question here for you, Akmal.
Yep.
Is how's the web version compared to the open source version?
Okay, right. So as you saw, that I was running the Spark in the Databricks environment, the CE Data Community Edition, and Kafka in the Confluent Cloud. So as far as I know, the open source versions of the technologies are the same. The only difference being that, I mean, you would download them, you would build them possibly, okay, maybe there are pre-built versions as well that you can utilize, and then you would have to set them up locally, configure them, set up all the necessary environments. And if you wanted to replicate and build your own cloud environment, you could do that, but it's a lot of work. So functionally, I believe they are equivalent, but obviously you saw there from the ease with which I was able to sort of configure and set things up, nothing for me to install. I just go to the web, it's point and click, configure, note down the credentials, the other details, and it's very, very simple and straightforward. And that is something that I certainly really appreciated. And I think from my experience talking to other people in the past as well, they do as well.
Awesome, thank you. Another question is, can you talk a little bit more about SingleStore pipelines, ingest, and Kafka?
Yes, so in the example that I showed, which I can again bring the code back up here. Okay, let's just take a look at this. Where is the pipeline here? Okay, so you recall from the visual representation, if I just go back in my slides a little bit and just show you this visualization, which I think is quite a nice one, that essentially what we have defined is something that is actually, you know, I can declare that in the managed service environment. It's a feature that's built in. It allows me to connect to a Kafka source, and in this case, it happens to be Confluence Cloud. And then from there, I can, you know, massively ingest the data directly into the SingleStore environment. I don't have to go to that producer consumer example that you saw me doing and struggling with a little bit earlier on. It works, of course, but this approach is far better. And then this notion of pipelines is just not just unique to Kafka. Of course, Kafka is the example I use today, but can work with other data sources as well. So you're not limited in that way. So again, this is something that is built into the environment. It's a part of the environment, comes as part of the package. It's not something you pay for extra, and therefore, you know, it's a feature that I think if you're looking to be able to ingest large quantities of data, as you saw, the particular scenario that I was trying to show was this kind of sensors sending in lots of readings, and this can do it in parallel, and it can read in parallel and ingest and be able to store that in the cluster sort of environment that we have. Far better, I think, than having to do so using JDBC. So I think that's a very useful feature, particularly if you want to get massive quantities of data into your database system quickly. And obviously, there is a reason why you would want to do that and be able to do your analytics and you know, your processing at scale.
Awesome. Last question here before we wrap up. Where does SingleStore fit in machine learning? Why would I use it?
Okay, so I think there you saw the main example that I illustrated in terms of the credit card fraud. We were mainly using SingleStore as our repository. We were pulling, we stored our credit card data in, and then subsequently we sort of pulled it out into the Spark environment. We ran our machine learning in the Spark environment. However, there are other possibilities. I mean, that is just one way that you could do machine learning. You could potentially be executing machine learning algorithms if you code them up correctly. You know, you could do Python code, for example, or you could create stored procedures or other sort of capabilities, plug into other libraries, and you could potentially execute those directly within the SingleStore environment as well. So that gives you even greater performance benefits, because now you don't have to run two separate systems. You can do it entirely within one. So machine learning, I think, is a great application area. Again, think about fraud, credit card fraud. And I've actually been the victim of that several times over the years. And I can't for the life of me figure out how is it possible that people got hold of these details when there is just give you an example, when there was a credit card that I kept as an emergency and I never actually used it ever in my life. And yet someone was able to get hold of those details and be able to use that. So in that case, building a kind of a real-time analysis, having these transactions arriving into your database management system, being able to execute a machine learning algorithm directly on the data as it arrives to determine, you know, is it fraudulent or non-fraudulent, and then be able to plug into sort of maybe the behavior of the customer. Is this the sort of transaction or is it the sort of purchase that they have done in the past? You could potentially hook into historical data. And again, that may be stored within your database environment as well. So SingleStore would be awesome for this type of application, because now you're utilizing the full power of the database management system, distributed computing, cluster computing, to be able to do that analysis and run those machine learning algorithms and store your historical data. So you can combine all of those capabilities in just the one product. I think that's where the real it will really shine. It will be a great benefit to use this single environment.
Another question here, Akmal. Can shard key find via the SingleStore Spark connector?
That's a great question. Let me take that offline, okay? To be honest with you, I don't know. I can check that for you. But thank you very much, whoever asked that question. If we can take the details, Diogo, so let's follow up with that. Alternatively, if you want to email me directly, it's simply achaudhry@singlestore.com. I'd be happy to follow up with that afterwards. But thank you very much. That's an awesome question, and I'll find out the answer for that.
Okay, I want to thank Akmal for the presentation. Thank you all for attending the webinar today. We will send you a follow-up email with today's recording and a link to our managed service free trial. We're offering each user $500 in credit, so you can start a full workload today. Lastly, check out our other virtual events at singlestore.com/events. Thank you for joining us and have a great rest of the day.
Great. Thank you, everyone. Thank you, Diogo. Thank you for everyone for attending, and have a great day, everyone. Thank you.